Welcome to Cosmic Facts. Today we are going to talk about one of the most extreme, most terrifying, and most fascinating objects in the entire universe. Objects so powerful that they bend space itself. Objects so dense that time slows down around them. Objects that consume everything that gets too close and never let it go. Not even light. We are talking about black holes. And by the end of this video, everything you think you know about space, time, and reality is going to change. Let us start from the beginning. But first, where do they come from? A black hole is born from death, the death of a star. But not just any star. To create a black hole, you need a star at least 20 times more massive than our sun. These stars burn so hot and so bright that they consume their fuel in just a few million years. For comparison, our sun will last another 5 billion years, but these massive stars burn out fast. And when they do, something catastrophic happens. For millions of years, the star has been held up by the pressure of nuclear fusion happening at its core. That pressure pushes outward and gravity pulls inward, and for millions of years they are perfectly balanced. But the moment the fuel runs out, that balance breaks. Gravity wins instantly. The entire star collapses inward in less than a second. The core gets compressed so violently that protons and electrons are forced together, forming neutrons. And if the star is massive enough, even that is not enough to stop the collapse. The core keeps compressing until it reaches a point of infinite density, a singularity. And around that singularity, space warps so severely that nothing can escape. Not gas, not dust, not light. A black hole is born. Now that you know how they are born, the real question is, what is actually inside? The boundary of a black hole is called the event horizon. It is not a physical surface. You cannot touch it. You cannot see it directly. It is simply the point of no return, the invisible line where the escape velocity exceeds the speed of light. Cross it, and the laws of physics as we know them guarantee you can never come back. But what is on the other side? What is actually inside a black hole? The honest answer is that nobody knows. And that is not false modesty. Our most advanced equations, the ones that have predicted every other phenomenon in physics with perfect accuracy, simply break down at the singularity. They produce infinities, numbers that make no physical sense. Some physicists believe that space and time swap roles inside the event horizon. That time becomes a direction you can move in, and space becomes something you are pulled through inescapably toward the singularity. Others believe the singularity does not actually exist as a point, but as something stranger that we do not yet have the mathematics to describe. The inside of a black hole is the edge of human knowledge, the place where our understanding of reality simply ends. But what would happen if you fell into one? At first, nothing would feel unusual. You would be in free fall, weightless, the same sensation astronauts feel in orbit. But as you got closer, something terrifying would begin. The gravity at your feet, slightly closer to the black hole, would be dramatically stronger than the gravity at your head. That difference would begin to stretch you. Slowly at first, then faster, then violently. Your body would elongate into a long, thin strand of matter. Scientists call this spaghettification. And it would happen before you even crossed the event horizon. But here is what makes it truly insane. To someone watching you fall, from a safe distance, you would appear to slow down as you approach the event horizon. Time near a black hole dilates so dramatically that from the outside you would appear to freeze at the edge and never cross it. You would stay there forever, getting dimmer and redder as your light struggled to escape the gravity. But from your perspective, time would pass normally. You would cross the event horizon without even noticing. Two people, same event, completely different realities. That is what black holes do to space and time. And if that terrifies you, wait until you see how big they can actually get. Not all black holes are the same size. The ones formed by dying stars are called stellar black holes, and they typically range from a few to a few dozen times the mass of our sun. But at the center of most large galaxies, including our own Milky Way, sit supermassive black holes that are millions or even billions of times more massive. Our own galactic center hosts Sagittarius A star, a supermassive black hole with the mass of 4 million suns, but even that is not the biggest. TON 618 is a quasar in a distant galaxy containing a black hole with 66 billion solar masses. Its event horizon alone is larger than our entire solar system. If you replaced our sun with TON 618, The event horizon would engulf every planet, every asteroid, every comet we have ever discovered. Imagine falling into a black hole feet first. And then there is Phoenix A. With an estimated mass of 100 billion solar masses, it may be the largest black hole ever discovered. Objects so extreme that they stop being just astronomical phenomena and become something closer to a fundamental feature of the universe itself. But not all black holes stay in one place. Most black holes anchor themselves at the centers of galaxies held in place by the gravity of billions of surrounding stars. But some are homeless. When two galaxies collide, which happens more often than you might think, their central supermassive black holes eventually spiral toward each other and merge. The collision releases an enormous burst of gravitational energy. And if that energy is released asymmetrically, which it almost always is, one of the black holes can receive a powerful kick. A recoil so strong it ejects the black hole completely out of its galaxy at millions of kilometers per hour. And now it wanders through intergalactic space, through the void between galaxies, completely invisible, undetectable, consuming anything that gets too close. There could be wandering black holes moving through the space between our galaxy and the next right now, and we would have absolutely no way of knowing until something got too close. So what eventually happens to them? Black holes seem eternal, consuming everything, growing larger, existing forever. But they are not eternal. In 1974, Stephen Hawking made one of the most shocking predictions in the history of physics. He calculated that black holes slowly lose mass over time through a process now called Hawking radiation. At the event horizon, quantum mechanics allows particle pairs to spontaneously form. Normally, they would immediately annihilate each other. But at the event horizon, one particle can fall in while the other escapes. The escaping particle carries away a tiny amount of energy. And since energy and mass are equivalent, the black hole loses a tiny amount of mass, infinitely slowly. Over timescales so vast, they make the current age of the universe look like a fraction of a second. But inevitably, relentlessly, the black hole shrinks. And one day it reaches a critical point and releases all its remaining energy in one final explosion, Eventon 618. With its 66 billion solar masses will one day evaporate completely. The universe will outlast every black hole ever created. Black holes are not just objects in space. They are the places where our understanding of reality ends, where the most fundamental laws of physics break down. Where time stops, space warps and matter disappears into something we cannot yet describe. They were born from the most violent events in the universe. They will outlive every star. And they are out there right now, consuming, growing, waiting. If this changed how you see the universe, subscribe to Cosmic Facts, because what we have not told you yet is even more insane.